This topic is called finding an x and y intercept of a line given the equation. And there's just a couple things before we dive into an example I want to remind you. At the x-intercept, that's just where a line crosses the x-axis. Our y value equals 0. And conversely, at the y-intercept, or where the line hits the y-axis, our x value equals 0. So you want to put that in your notes because it's a good thing to remember. Let's just do an example now. Let's say we have an equation of 2x minus 8y equals 9. To find the x and the y-intercept, we have to do it in two steps. First, for the x-intercept, since I said a minute ago that at the x-intercept y is 0, we're going to put in 0 for y. We're going to recopy the equation. Wherever we see a y, we're going to put in 0. So 2x minus 8, there's a y value, so we're putting in 0, equals 9. So now we simplify, we do that multiplication out. 2x minus, what's 8 times 0? It's going to be 0, equals 9. Well, it's kind of silly to write out 2x minus 0 equals 9. We'll just write out 2x equals 9. And now use your algebra skills. If we have 2x equals 9, how do we solve for x? We need to get rid of the 2, undo the multiplication by dividing, and our x-intercept is 9 over 2. You could also say put 4.5 if you want. Either way, doesn't really matter. So that's how you find the x-intercept. Luckily, the y-intercept is very much the same type of thing. However, as I said up above, at the y-intercept x is 0, so we're copying over the equation that they gave us. But this time, wherever we see x, we're putting in 0. So 2 times, there's an x value, we put in 0, minus 8y equals 9. We need to find the y value for when the x is 0. 2 times 0, that's 0. So we have 0 minus 8y equals 9. We can get rid of the 0 and just leave it as negative 8y equals 9. How do we solve for y? Divide through by negative 8. And our y-intercept is 9 over negative 8. Or you could just say negative 9 over positive 8, either way. And there you go. A lot of times you'll get ugly answers for these, which makes sense because in the real world you're not going to cross the x and y axes at these beautiful places. They're going to be just ugly with decimals and fractions and stuff, so that's just life. Let's try another one. Alright.
Did it start yet?
Yes, it started, Melanie. You're now on record. Alright, here is another example. We're going to find the x and y intercept, and the equation that we're given is 6x minus 9y plus 6 equals 0. Same deal as the last time. If we're looking for the x-intercept, we're going to let y equal 0. So we're copying over the equation that they gave us. Wherever we see an x, we're putting in a 0. And then we're going to solve for x. Alright, 6x minus 9 times 0. What's 9 times 0? 0. Now we can combine the 0 and the 6, so we just end up with 6x plus 6 equals 0. Bam, this is your two-step normal algebra equation. We need to solve for x. First we subtract this 6, canceling it out. 6x equals negative 6. Then we divide by 6, and we get x equals negative 1. That's not so ugly. So our x-intercept of that line is negative 1. Now to get our y-intercept, we're going to plug in to the equation that they gave us, x equals 0. Alright, 6 times x becomes 6 times 0 minus 9y plus 6 equals 0. We have to solve for y now. 6 times 0 is 0, so we have 0 minus 9y plus 6 equals 0. We don't need that 0 there, but remember that that negative sign is married to the 9, so it has to stay in our equation. And now we're at the same spot as the previous side of the line here. We have to solve for y. Two-step equation, so we subtract a 6. Negative 9y equals negative 6. And now we divide both sides by negative 9. And two things happen here. We have negative divided by a negative, so that's going to give us a positive number. Plus we need to reduce. The 6 and the 9 can both be reduced by 3. 3 goes into 6 2 times. 3 goes into 9 3 times. So our y-intercept happens at 2/3. And just to kind of give you an example of how this might help, when would I ever use this, that is one way to be able to graph the line. So if we know that the x-intercept is at -1, we can put a dot at -1. And if we know that the y-intercept is at 2/3, we can put our dot at 2/3. And you can connect those lines, hopefully with a ruler, which I didn't use this time. Connect them and you got a beautiful graph for your line. So it is another way to graph a line, is if you have both equations. That's one way to do it, or both intercepts, sorry. Alright, one last problem. I want you to try this. Actually, what I want you to do this time is I want you to copy it down in your notebook, hit pause, and work it all out in your notes, and then come back and hit play and see if you got the same answer that I got. Alright, so let's say that our equation is 4x, we'll do plus 10y, minus 3 equals 0. I want you to find the x-intercept and the y-intercept for that equation. So hit pause and go do it. Alright, for the x-intercept, same as before, we copy it over. Wherever we see a y, we put in 0. 10 times 0, minus 3. 4x, 10 times 0 is 0, so we can just get rid of it. Now to solve this two-step equation, we add a 3 to both sides. It's gone from that side. Now we have 4x equals 3. Divide both sides by 4, and x equals 3/4. Not 3/3, 3/4. Alright, now to find the y-intercept. Almost the same deal. We're putting in x equals 0. So 4 times 0 plus 10y minus 3. 4 times 0 is 0. We don't need to rewrite it. So we just have 10y minus 3 equals 0. Solving for y, we add a 3 to both sides. And then the final step, the 10's multiplying with the y, so we divide both sides by 10, and y equals 3/10. Again, not super pretty, but it works. If you have any issues, you're not quite sure why I did certain steps, come find me and I'll see if I can clarify for you. Thanks.